5 disasters. Dams and bridges, same nightmare pattern. One weak point, then total collapse. Counting down from 5 to 1. Stay for number 1. One tiny limit that turned into a mega flood.
Number 5. Tacoma Narrows Bridge. Washington, 1940. Brand new, beautiful, and so flexible it got a nickname on day one. Galloping Gertie. Even mild wind over the Narrows made the roadway ripple, like it was alive.
Here's the weak point, not a cracked cable, the deck. Solid plate girders acted like a wall, trapping wind pressure instead of letting air pass through. The bridge was light, torsionally soft, and the wind didn't just push it, it started steering it.
Then the motion flips from bouncing to twisting. Aeroelastic flutter, self-excited, growing cycle after cycle. No impact, no sabotage, just physics feeding energy into the structure like an amplifier with no mute button.
Around 11 a.m., hangars start snapping. The center span rips loose and the whole roadway plunges into Puget Sound. After this disaster, wind tunnel testing becomes standard for long bridges because sometimes the weakest point isn't steel, it's stability.
Number 4, the Silver Bridge, Ohio River, 1967. Evening traffic, cars stacked at a stoplight. Instead of thick cable bundles, it hung on I-bars, giant metal links. And this design had almost zero backup.
The weak point was one piece, I-bar 330. Inside its eye, a tiny defect grew, stress corrosion and corrosion fatigue, until it reached critical size. A flaw 1/10 of an inch deep became a death sentence.
When I-bar 330 fractured, the bridge had almost no redundancy. Load jumped, pins shifted, the chain severed, and the whole suspension system lost equilibrium. In seconds, the deck folded and slammed into the river.
46 people were killed, and it changed inspections forever, because looks fine means nothing when the weak point is hidden inside metal. Next up, a modern collapse, caused by a part most drivers never notice.
Number 3. Minneapolis, August 1st, 2007, the I-35W bridge. Afternoon rush plus construction work. Witnesses heard a sharp boom. Then the steel truss started buckling and the roadway dropped out from under traffic in seconds.
The weak point wasn't the big beams, it was the connections. Gusset plates, flat steel joints that bolt truss members together. Think of them like the bridge's knuckles. If one tears, the frame can't hold shape.
Investigators found key gusset plates were undersized from the original design. Too thin. Add concentrated construction materials parked on closed lanes, and that one joint hit its limit. One thickness decision, and the geometry collapsed.
About 1,000 feet of bridge fell into the river. 13 dead, 145 injured. A structure failed because one connection was sized wrong. And now, number 2 shows dams can fail too.
St. Francis Dam, California, 1928. Built fast to feed a growing Los Angeles. From the outside, it looked unstoppable, but inside the canyon, seepage and cracking were warning signals. Pressure was rising by the hour.
The weak point wasn't the concrete, it was what the dam sat on. One abutment rested on fractured rock that lost strength when soaked, and engineers kept raising the crest, adding weight, without fully recalculating how much that ground could carry.
Just before midnight, the dam catastrophically collapsed. The reservoir released as a roaring wall of water, like a liquid landslide, charging down San Francisco Canyon, tearing out roads, camps, and neighborhoods in minutes.
At least 431 people died. The lesson is brutal. If your foundation is wrong, the whole dam is wrong. And number 1 is the ultimate cascade, when one bottleneck turns extreme rain into a regional catastrophe.
Number 1, Banqiao Dam, Henan, China, August 1975. A typhoon stalled overhead and dumped extreme rain for days. Reservoirs filled to the rim. Operators needed time, but the water didn't negotiate. The system was about to snap.
The Banqiao Dam held a staggering volume of water until its most critical vulnerability was exposed. The weak point was capacity, how fast it could safely release water. Discharge paths were inadequate, and communications went down, delaying warnings and critical decisions.
Overtopping began, and once an earth dam is overwhelmed, erosion can race. Banqiao failed, then dozens of dams failed after it, sending flood waves across the plains, cutting roads, power, and escape routes in the same blow.
D-death toll estimates range from tens of thousands to far higher. One storm plus one critical bottleneck turned into one of the deadliest engineering disasters ever recorded. That's what one weak point really means.
If you made it to number 1, drop the words weak point in the comments. Which failure rocked you the most? 5, 4, 3, 2, or the top spot? Smash subscribe to Fact Surge X for more.